Alright, so I'm going to be talking about how to use a spirometer to analyze certain lung function parameters. Those parameters being tidal volume, vital capacity, inspiratory reserve, and expiratory reserve. Now it doesn't matter which spirometer you use. It could be a go-direct spirometer or our older spirometer. The analysis is the same, and even the view and how you collect data would look very similar in graphical analysis 4. Now, you don't need the flow rate to do this analysis, so I'm going to make it so that we only see volume. To do that, you go up to the right-hand corner, and you tap on this icon, and you can select one graph. And then I'm going to tap on the y-axis and change that to volume and deselect flow rate. Now, what I'm going to do is I'm going to take a series of normal breaths, and then I'm going to inhale as hard as I can, and then exhale as hard as I can, and then you'll see a series of recovery breaths. And I'm just going to collect that data with the volume off. So let's just do that now. All right. So what I'm going to do before I analyze this data is I'm going to maximize the view. And I'm going to do that by tapping on this icon down here, which will zoom to all the data. All right. Now, these normal breaths are what we would use to calculate the tidal volume. And the tidal volume is really just the difference between the peak volume during that breath and then the valley that follows it. So if you know what the peak value is, and then you know what the value is of the trough that follows it, and just take the difference, that would be the tidal volume for that breath. There's also a really nice feature in graphical analysis that does this automatically, but you have to select a region to do that. So I'm going to click and drag to select a region, and I'm going to make sure that I get this peak and the valley that follows it. And then I'm going to go down to this icon, which is the Graph Tools icon, and I'm going to select View Statistics. And when I select View Statistics, you'll see that it'll show me the delta Y value, which is the difference, and that is 0.815 liters. So for that tidal volume, that was 0.815 liters. I could do that for another breath, and in this case do the same thing, just say View Statistics. And you can see that the delta Y value in this case is 0.837 liters. Now, what about vital capacity? Well, the vital capacity is the range or the difference between the maximal inhalation and the maximal exhalation. So if I do the same thing, if I select the peak for the maximal inhalation and the valley that represents the maximal exhalation and get the difference, that will be vital capacity. So in this case, the vital capacity is 3.445 liters. And that makes sense for me. I'm of normal build. My vital capacity ranges from 3.4, 3.5, sometimes even 4 liters, depending when and how I measure it. All right, what about inspiratory reserve? Well, inspiratory reserve is this range of the graph. So if you know what the peak inhalation was, in this case it's 2.8 liters, and you know what the tidal volume was that preceded it, and you calculate the difference between those two, that would give you the inspiratory reserve. The expiratory reserve can just be calculated once you have tidal volume, vital capacity, and inspiratory reserve. But I can also show you where this is on this graph. The expiratory reserve volume is really the difference between this valley and this valley here. So it's that range from the valley before you take that big inhalation, and then what is the maximal exhalation. And if you take the absolute value of that, that would give you the expiratory reserve. And that's really how you would do this experiment. You calculate a series of tidal volumes. You then calculate the vital capacity. You then calculate the inspiratory reserve and expiratory reserve. And that's how you do this experiment where you analyze lung volumes.